So today we're going to talk about arithmetic series. And what a series is, it's basically the sum of all the terms in a sequence. So when I talk about an arithmetic series, I'm talking about adding all the terms, first term through the last term, of a series that has a common difference pattern. And this is kind of a famous problem where you're adding the numbers from 1 to 1,000,000, which by hand or by calculator would take forever for the most part. And a famous mathematician came up with a unique way of solving this. He took and wrote the entire series backwards. So I'm just going to change the order of everything. And he came up with a pretty interesting finding. He found that no matter what arithmetic series, this is a huge one, but I could write smaller ones, but he found that for any arithmetic series, is if you write that series backwards and then add up the sets of terms, like in this case, I add this and I get 1,000,001. And I add this and I get the same thing, 1,000,001. And I add this and I get 1,000,001. And this happened all the time, every time he did this for an arithmetic series. And he said, well, wait a minute. And this guy actually did this back in the days where there were really no calculators. I'm sure they had abacuses and all that kind of stuff, and most of the stuff was done by hand. All right. He found that if I add these two up, I don't necessarily get the sum of the whole thing, but I would get twice the sum of the whole thing because I've added two series up. So he said, well, look what I've done. Essentially, I've taken this first term and the last term and found the sum of that, because the sum of the first term and the last term is the same as the sum of every other term. So he said, if I take that first term, add it to the last term, and how many of those sums do I actually have? Well, I have n number of terms, and he knew how to do multiplication pretty well. Then what I have is I don't have the sum, but I have twice the sum. So if I just divide that by 2, I get the sum of the n terms. And he found that this equation was actually the equation for a series of any arithmetic sequence. And the amazing thing about this is the mathematician who came up with this whole process, his name was Gauss, Gauss, G-A-U-S-S. Gauss, he did this when he was 10 years old. Went on to do a whole bunch of other stuff mathematically and in physics later, but came up with this notation when he was 10. Pretty amazing. So that equation, once again, is the sum of n terms. So the sum of a series, S sub n, is equal to the number of terms in the series multiplied by the first term added to the last term, all divided by 2. And again, this is kind of an important equation to know. And it only works, once again, for an arithmetic series. So what we're going to do now is we're going to find the sum of the first 40 terms in this series. Now it's arithmetic because we know our common difference is equal to -3. But you'll notice the common difference isn't used in this equation. I need the first term, which in this case is 8. I need the last term, which I don't have. I need the total number of terms, which I do have, is 40 terms, over 2, to get the sum of the first 40 terms. So I've got everything but this 40th term. But luckily, from our last lesson, we can find the 40th term in a sequence. So I know if I want to find the 40th term in an arithmetic sequence, I need my first term, my common difference of -3, and the number of terms that I'm looking for. So now we have 8 plus -3 times 39 is going to be that 40th term. So basically, we're going 8 minus 3 times 39, which is going to be negative 109. And now that I have that my 40th term is negative 109, I can pop into the equation 48 plus negative 109 over 2 gets me my sum, which in this case is negative 99 times 20, which is negative 1980. So we're using not only the sequence problem, but the new series problem to get this done. Find the sum of this series. Now in this case they gave us that last term, which is great. So we want to find the sum, but we don't know n. Of n number of terms is equal to n. We have the first term and we have the last term over 2. I don't know how many terms we have, but again we can use the sequence formula. We have 95, which is the nth term, is equal to the first term plus the common difference, which in this case is 6, times n minus 1. I can solve for n. I have 90 is equal to 6 times n minus 1. I know 90 divided by 6 is just going to be 15. And that gives me n minus 1. So 16 equals n. And now that I have n, I can find my sum. So I have the sum of the first 16 terms is equal to 16 times, this ends up being 100 over 2, which ends up being 800 for the sum. Now I'm going to be given a common difference. I'm going to be given the 18th term, and I want the sum of the first 18 terms of that sequence, or yeah, of that series. So in this case, I need the number of terms, which I have. There's 18. I need the first term. Don't have that. I need the last term, which I have. That's 72 over 2. We go back to our sequence formula and say 72 equals that first term, which I don't know, plus that common difference, which I have. Number of terms is 18 minus 1. So we have 72 equals that first term plus 7 times 17. So I take 72 minus 7 times 17, which gives me negative 47 for that first term. I just plug into my equation now. Sum of the first 18th terms is 18 and negative 47 plus 72 all over 2. 72 minus 47 gives me 25, and that is a positive, and that's a 9, and 9 times 25 is just 225. Now, this is a little harder. We want to find the sum of the multiples of 3 between 1 and 2000. Now, this isn't saying add up 1 plus 2 plus 3 plus 4 plus 5, etc., etc. It's saying add up the sum of the multiples. So the first multiple of 3 between 1 and 2000 is 3. The next one is 6. Then 9, etc., etc. So I'm looking basically to add 3 plus 6 plus 9 plus 12 all the way out until I get to the last multiple of 3 between 1 and 2000. Now I got to figure that out. I know 2000 over 3 doesn't work. But if I go 1998 divided by 3. That might, not so sure, but I can try it. Ends up being 666. So this is my last multiple of 3. So the next thing I need to do is find the sum of this series. So I have my series, but I don't know the number of terms. This looks familiar. Is equal to an unknown number of terms multiplied by the first term which I have, the last term which I have, over the number of terms. So now it's back to our sequence formula where we know the last term, we know the first term, we know the difference, which is 3, and we don't know the number of terms. Do our subtraction. That's 1995 is equal to 3 times n minus 1. Take 1995, divide that by 3, get 665 is equal to n minus 1. So we have 666 is equal to n. And now we plug it in. The sum of 666 terms is equal to 666 plus 2001 over 2. We end up with 666,333. Next, we want to find the first 3 terms of a sequence given the first term, the last term, and the sum of all the terms. But we don't know the number of terms. So in this case, we have the sum is equal to the number of terms, which I don't know, multiplied by the first term plus the last term over 2. So now I can find the number of terms in that sequence. I multiply by 2 to the other side of the equation, and I get 4494 is equal to 214n, and then I divide and end up with 21 terms. And I want the first 3 terms in a sequence where this is my first term. Let's see if I can do that. I need the nth term, which I have, 197. I need the first term, which I have, of 17. I need the common difference, which I still don't have. And I need the number of terms, which now I have, 21. So now I should be able to find that common difference. Bring this over. I have 180 is equal to 20d. So the difference in this case is equal to 9. And now I can find all my terms because I start with 17, add 9 to 17, get 26, add 9 to that, get 35, and there's my first 3 terms. So what I want to do here is I want to find the sum of a series generated by this general equation, and they're going to be 1 to 107 terms, so total of 107 terms. So if I begin to do this, I plug in 1 and I get 2 times 1 plus 7, and then that gives me my first term of 9. Then I increment by 1, plug in a 2. get 11. Increment 1, plug in a 3. End up with 13. Increment 1, plug in a 4. And you're starting to see the pattern is arithmetic. So if it's arithmetic, what do I really need? I need how many terms, and I have 107. I need that number of terms multiplied by the first term, which I now have. I need the last term. I need a sub n over 2, and that'll get me my sum. So if I want the last term, all I need to do is plug in 107. So I'm just going to go dot, 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 and then plug in 107 to 2n plus 7. So I end up with 221, and I can put my 221 as my nth term. And then now I just grind this out. I take basically 230 times 107 and divide that by 2. And that's going to get me 12,305. Let's just do a couple more for practice. We're going to develop a pattern here, and then we will find this guy over here. So notice, in this case, we're finding the sum of the series generated by n plus 8, that equation, but we're starting with n equals 4 and going to n equals 6. So notice, I plug in 4, I get 4 plus 8, which is 12. I increment by 1, that's 5 plus 8, which is 13. And then I increment by 1 more till I get to 6, and that's 6 plus 8, which is 14. So I started at 4, ended at 6. I have a total of 3 terms. I add those guys up. That's 25, 35, 39. And that's that solution. Now in this case, I start plugging numbers in. Plug in a 6, and I get out 62. Plug in a 7, I get out 72. Plug in an 8, I get out 82. And I keep going until I plug in a 64, which ends up being a total of 642. It's clear to see that this is a pattern that's arithmetic, so it's an arithmetic series. But the question is, how many terms do I have? Because I have my first term, which is 62. I have my last term, which is 642. I'm going to divide that by 2, but I need how many terms are in the sequence. Well, if I'm going from 64, or from 6 to 64, one might think there's 58 terms. But that's not true, because I went from 4 to 6, and I actually had 3 terms, not 2. So really what you need to do is you need to take the top, 64, subtract from the bottom, and then add 1, because you have to include counting the 6th term. Alright? So we end up with subtracting 58, adding 1, getting 59 terms. And this will get me the sum of these 59. And I plug all that into my calculator, and I end up with 20,768.